Okay, everybody, good morning. Today we're going to do the pure free mathematics specimen paper with Miss Hayden Higgins. Okay, now again, make sure that before, try every question before, pause it, and then look at the walkthrough. Question 1. The point P, 7 minus 2, lies on the curve of the equation y equals f of x. State the coordinates of the image of P under the transformations represented by the curve with the equation A, y equals f of x plus 4 plus 1. Okay, so for the first part, inside or outside the bracket? Inside the bracket. Who does it affect? X. And it's a transformation, we're going to move it to the left. Okay, so it's a translation. So we're going to minus 4 from all the x coordinates. Inside or outside the bracket? Outside, who does it affect? Y. And we're going to add 1 to all the y coordinates. So if our coordinate was 7 minus 2, if we minus 4 from the x coordinates, and then add 1 to the y coordinates, we're now going to have 3 minus 1. Part B. Y equals f of minus 2x plus 7. Okay, inside or outside the bracket? Inside, it affects x, and we're going to do the opposite of what it says. It says multiply by minus 2. We're actually going to divide by minus 2. Then we have plus 7. Inside or outside the bracket? Outside, it affects the y. What we're going to do, what it says, and we're going to add 7. So if our coordinate was 7 and minus 2, now for our x coordinate, we're going to divide it by minus 2, so we're going to get minus 7 over 2. And for our y coordinate, we're going to add 7. So minus 2 plus 7 is 5. So nice and easy, 4 marks for the first question. And again, this is just an extension really on pure 1. Question 2. It says using the identity cos of A plus or minus B, prove that. Okay, so they've told us which identity to use. It's in the formula sheet, okay? And we need to prove cos of 2A. Well, hold on a minute. 2 lots of A. A number plus a number is going to give me 2 lots of A. What's it going to be? A plus A. So I'm going to use the identity. So we know from the formula sheet, cos of A plus B equals cos A cos B minus sine A sine B. Now, the only way we can get cos of 2A is if we add 2 A's together. So we're going to have cos of A plus A equals cos A cos B minus sine A sine A. Okay? Now, that means that cos of 2A equals cos squared, oh, sorry, that was a mistake, that should have been an A. Cos squared A minus sine squared A. Okay, what do we know about cos squared minus sine squared? Well, first of all, we know, and I always like to write this down, we know that cos squared A plus sine squared A equals 1, using our common sense. In our final answer, we want sine squareds. So I'm going to rearrange this to get cos squared equals so that I can get rid of this cos squared, because I don't want it. It's not what it wants. So then we're going to have cos squared A equals 1 minus sine squared A. I'm going to substitute that in. So now I have cos of 2A equals, and instead of cos squared A, I'm going to write 1 minus sine squared A. 1 minus sine squared A minus sine squared A. That's going to give me 1 minus sine squared A minus sine squared A is in fact minus 2 sine squared A. So cos of 2A equals 1 minus 2 sine squared A. Therefore, proved, part A. Now, just a note here, in the mark scheme, it says, well, it doesn't specifically say for part A, it just says attempts the compound angle formula and applies cos squared equals 1 minus sine squared. Even you might know this, write it down. When in doubt, write it out. Okay? Right then, part B. Hence, okay, if something says hence, that means use what we've just figured out in a nice way, or use something that we've just used. Hence, find, using calculus, the exact value of the integral of pi over 4 and 0, 3 lots of sine squared to x with respect to x. Okay? Now we know that sine squared 2x with respect to x. What do we know that is? What could we use from earlier that's going to help us with this? So, first of all, we can take out a factor of 3. So we can have the integral of pi over 4 and 0, and if we take out a factor of 3 on the outside, okay, and we just have sine squared of 2x with respect to x. Now, where else have we seen a sine squared in the question earlier? We've seen it here. Okay, so we're going to rearrange this. So, cos of 2a, I'm going to rearrange it the other way around actually. Right, so is everyone happy if, no, I'm going to do it step by step. Cos of 2a equals 1 minus 2 sine squared a. So if I move the sine squared to the other side, I'm going to get 2 sine squared a equals 1 minus cos of 2a. So that means that sine squared of a equals, I divide everything by 2, a half minus a half cos of 2a. Okay, I've just used simple rearranging. Now in our case, our a is 2x. So therefore, sine squared of 2x equals a half minus a half cos of 2 lots of 2x, which is 4x. So now that means we're going to have the integral between pi over 4 and 0, with our factor of 3 on the outside, of a half minus a half cos of 4x with respect to x. Now we now know how to integrate that. So for part B, if we integrate that, if we integrate a half, we get pi over 4 and 0. If we integrate a half, we're going to get half x, increase the power by 1, divide by the new power. If we integrate negative cos, again, let's get our special sine, cos, minus sine, minus cos. Differentiating is clockwise, integrating is anti-clockwise. So if I integrate negative cos, I'm going to get negative sine, negative a half sine of 4x, and then what are we going to do? We're going to divide it by the differential of the bracket. Okay, it's chain rule. If we divide it by the differential of 4x, which is in this case is 4, so minus a half divided by 4 is going to turn into minus 1 over 8. Okay, we've got 3 lots of this. Now, what we're going to do is we're going to put in the values of pi over 4, and we're going to put in the values of 0 and take it away from each other. So, we're going to have, I'm going to multiply everything by 3 as well. I'm going to have 3 lots of a half lots of pi over 4 minus 1 over 8 sine of 4 lots of pi over 4 we know is just pi. This is going to be minus 3 lots, and now I'm going to substitute in my 0. A half lot of 0 minus 1 over 8 lots of sine lots of 0. I'm going to carry this one up here now. Now, a half times pi over 4 is pi over 8 multiplied by 3. It's 3 over 8 pi. Okay, and then sine of pi is 0. So we're going to get minus 1 over 8 times 0. So that's minus 0. Then we're going to have a half times 0 is 0. Sine of 0 is also, in fact, 0. So this actually is completely 0. So my final answer is 3 over 8 pi. Question 3. Guinea pigs and rabbits were introduced onto an island at the same time. The number of guinea pigs, G, T months after they were introduced onto the island is modelled by the equation. G equals A plus 60e to the minus 0.052, where A is a positive constant. The number of rabbits, R, T months after they were introduced onto the island is modelled by the equation. R equals 100 plus, given that there were twice as many guinea pigs as rabbits onto the island, find the value of A. Okay, a lot of information to digest there. But these are both the formulas, okay, of the initial, at the same time, okay? So there are twice as many guinea pigs as rabbits, okay? Twice as many guinea pigs as rabbits. So that means that for every one guinea pig, no, twice as many, so for every, so then we're going to have A plus 60e to the minus 0.05t is 2 lots of our rabbits, which is 100, plus 80e to the 0.05t. Okay? Need to solve this. A equals 200 plus 160e to the 0.05t minus 60e to the minus 0.05, no, minus 0.05t. Okay. So, what can we establish from this? So then, we know if we can set the time to be 0, we're going to have A equals 200 plus 160 e to the power of 0 is 1. minus 60 and e to the power of 0 is 1, which is 300. So A equals 300. Part B. When t equals t, the number of rabbits on the island is equal to the number of guinea pigs on the island. Using these models, find the value of t, given your answers to one decimal place. So now we're going to put the equations equal to each other and find value of t. So we know our A is 300, so we're going to have 300 plus 60e to the minus 0.05t equals 100 plus 80e to the positive 0.05t. So that means I'm going to have, if I move everything to the left hand side, 80e to the 0.05t negative plus 60e to the minus 0.05t plus 200 equals 0. Okay, this is basically a form of a hidden quadratic. Okay, it's hidden. So we're going to multiply everything first by e to the power of 0.05t. The reason why we're going to do that is you'll see in a minute. Minus 80e to the 0.05t, if I multiply that by e to the 0.05t, if the bases are the same, what do we do to the powers? We add them. So we're going to have negative 80e to the 0.1t. Then 60e to the minus 0.05t multiplied by this. 0.05t add minus, this is going to be 0. E to the power of 0 is 1. So we're going to get plus 60. Then 200 to the power of e to the 0.05t equals 0. Now you're going to notice, well, they're all also a factor of 20, aren't they? So I could divide everything by 20 here just to make life a bit easier. So we're going to get minus 4e to the 0.1t plus 10e to the 0.05t plus 3 equals 0. Okay, now we know e to the 0.05t squared equals e to the 0.1t. Okay? So we could then say that that is technically y squared. Just, it's a hidden quadratic. So minus 4y squared plus 10y plus 3 equals 0. Okay, so we have two answers when we solve this using the quadratic equation. 5 plus root 37 over 4, which is roughly 2.77, and 5 minus root 37 over 4, which is a negative number. Now, we can't really have e to the power of something give us a negative number. Okay, we're talking about population growth, aren't we? So we're going to reject this one. I'm going to focus on this number here. So we know then that our y equals 5 plus root 37 over 4. So that means e to the power of 0.05t equals 5 plus root 37 over 4. Now I have one e on one side and we have an equation. How do I now find t? I learn both sides. So we're going to have ln of e, which we know is just 0.05t, equals ln of 5 plus root 37 over 4. How am I going to find the value of t? I'm going to divide both sides by 0.05. So t equals ln of 5 plus root 37 over 4 all divided by 0.05, which is the same as multiplying by 20. Okay, which is 20.3819 ... Please always make sure you write that out. And then we go back to the question, and it says give your answer to one decimal place, okay? So that actually means that t equals 20.4. Question 4. Solve for 0 is less than or equal to theta is less than or equal to 2 pi. Okay, stop what you're doing and make sure that your calculator is in radians. Check. Okay. 3 lots of sine 2 theta plus 5 cos of 2 theta equals 4. Right. Immediately, when I look at this, how am I going to solve this equation? Okay. I've got 2 thetas, 3 lots of sine something, 5 lots of cos something. We should be thinking of our sine. It's not in the formula book, okay? So this is what it's not here, is it? Okay? So, we need to memorize this. So we know that our sine, or we could have used cos, okay, of theta plus alpha equals. And what does it equal? We know to find out what it equals, we can actually use the addition formula. So that means I'm going to have sine theta cos alpha plus cos theta sine alpha. Okay, so now what we need to do is, obviously, we need to equate coefficients. So what do we know? First of all, we know that our theta is in fact 2 theta. Okay, so I know I've used theta here, but in the question we have 2 theta, so this needs to become a 2 theta. So I'm going to change that now. So we've written the formula and then we adjust it to make it fit our question. What else do we know? We know that sine 2 theta is multiplied by 3. So that means that cos of alpha equals 3. And the same on the other side. Cos 2 theta is multiplied by 5. So here that means that sine of alpha is 5. So we know sine alpha equals 5. We know that cos of alpha equals 5. What do we know about sine and cos? Silly cow. Sine of alpha over cos of alpha equals... Nope. This is a 3, isn't it? Cos theta, yeah. Equals 5 over 3. What else equals 5 over 3? Tan. So I know that tan of alpha equals 5 over 3. To find alpha, I'm going to do the inverse of 5 over 3, which is 1.0303. It says give each answer to 2 significant figures, so that means we can say that alpha equals 1.03. So we figured that out. Now we've got to figure out R. So we know that R is in fact equal to the square root of 3 squared plus 5 squared. 3 squared plus 5 squared. If you don't know why this is, please go back and watch the video on this chapter where it's all explained there. Which equals 9 plus 25, which is root 34. So now, what do we have? If we were to rewrite this, therefore, root 34 sine of 2 theta plus our alpha, which is 1.03, equals 4. Because we've rewritten this in terms of one trig function so that we can solve it. So there we go. Now we're at this stage, we can solve this. So, step 1. Sine of 2 theta plus 1.03 equals 4 over root 34. So that means 2 theta plus 1.03 equals the inverse of sine of 4 over 34, which is 0.7559. Okay, and it keeps going. What we're going to do is we're going to round it to 3 significant figures, okay? Because in the question it wants 2 significant figures. If we round it to 3 right now, we're going to try and keep it as exact as possible. So we're going to use 0.756. Okay, so we found our first value. So what we're going to do is we're going to do this slightly different. First, we're going to draw our CAS diagram ready. So C, A, S, T. We know this is 0. We know this is pi. We know this is pi over 2. This is 3 pi over 2. Now, pi is 3.14. So pi over 2 is roughly 1 point something. We've got 0.76. So we know our angle is here. Okay? This is 0.76. Sorry, 0.756. This same angle is also reflected here because we're looking at the sine graph. So we have 0.756. Perfect. So that's step 1. Step 2, we need to adjust our interval because we actually have 2 theta plus 1.03. Here we've just got theta. How did we get from one to the other? Step 1, we multiplied everything by 2. So that means 0 is less than or equal to 2 theta is less than 4 pi. Then what did we do? We added 1.03. So that means 1.03 is less than or equal to 2 theta plus 1.03 is less than or equal to 4 pi plus 1.03. Now we have the interval. We're going between 1.03 and 4 pi plus 1.03. Now we know that 1.03 is more than 0.756 but less than pi over 2. So it's about here, isn't it? Okay, this is 1.03. I mean, again, diagram's not drawn accurately. This is just to show you. So it says we start at 1.03. Anything less than that, we don't. So if I start here, we're not starting at 0 because we have to start here. So I start here and I go around until I hit my first pink line because this is where we've established is where it crosses. Okay? The solutions. Okay, my first pink line. Pi minus 0.756. So if I put that into my calculator, I'm going to get 2 theta plus 1.03 equals 2.3855. Now, it very clearly says that we want it to 2 significant figures at the end. And, you know, in terms of rounding errors and consistencies, what I'm going to do now is I'm going to keep going to find theta. So I know then that 2 theta is 2.3855 minus 1.03, which is 1.355, and theta is then divide that by 2. So I'm going to get 0.6777. So my final answer, if we're rounded to 2 significant figures, is 0.68. So there's my first solution. Okay, and again, because we want to be as exact as possible, I'm going to do each one that way. For my second solution, I'm now here and I keep going all the way round. We've reached 2 pi, so we're going to do 2 pi plus 0.756. 0.756, which is going to give me 7.039. Again, if I minus 1.03, I'm then going to get 6.0091. Divide that by 2. I'm going to get 3.004 to two significant figures. That is going to be 3.0. Okay, now the reason why I've done it this way is because actually earlier what I did was I had 7.039, and obviously it goes on ... If you put into your calculator 7.039, then you minus 1.03, then you divide it by 2, I get 3.0045, but what I did was I did 7.04. So 7.04 minus 1.03, then divided it by 2, and I ended up with 3.01. So I actually had a rounding error, so just be careful. Then, if we carry on going round again, because we've got to get all the way up to 4 pi, okay, and this we've just passed 2 pi now. Carry on, we get to here. This is 2 pi, this is 3 pi. So 3 pi minus 0.756 is going to give me 8.668. If I minus 1.03, I'm going to get 7.638, and then divide by 2, 3.819 to two significant figures, that's 3.8. And then we keep going round again. Use a different colour this time, so I'm here. Keep going round. Remember, I'm going to 4 pi plus 1.03. So now I've reached 4 pi. 1.03 is here, so I keep going. Yes, I've hit somewhere. So I'm going to get 4 pi plus 0.756, which is going to give me 13.322. And then I'm going to minus 1.03, which is 12.2923, ... Then I'm going to divide by 2, and I'm going to get 6.146 to two significant figures, that is 6.1. So now I have my 4 answers, because if I was to carry on going round, I stop at 4 pi plus 1.03. I see there's nothing else there is no intersection. So my final answer is theta equals 0.68, 3.0, 3.8, and 6.1. Again, if you're not sure how to use a CAS diagram properly, please make sure you look at a video of the chapters I've done. Okay, question 5. A function f is defined by f of x equals 7 over x plus 3 minus 5x plus 22 over x squared plus 7x plus 12. Show that f of x can be written in the form a over bx plus c, where a, b, and c are constants to be found. Okay, don't know if anybody spotted it, but on the second fraction, I'm thinking this factorises x plus 3, x plus 4. So that means if we need to add or take away, I need to multiply the first fraction by x over 4, x plus 4 over x plus 4. Okay, because again, we're multiplying it by 1, so we're not changing the value. So I'm going to get 7x plus 28 over x plus 3, x plus 4, minus 5x plus 22 over x plus 3, x plus 4. Now, on my numerator, I'm going to have 7x plus 28 minus 5x plus 22. Now, watch out for this negative, because a lot of people just do minus 5x and then they add the 22. That's clearly not the case here. X plus 3, x plus 4. Okay? Now, so we're going to have 7x minus 5x, which we know is 2x. Then we're going to have 28 minus 22 which is 6 over x plus 3, x plus 4. Now it's told us that we're going to have a bx plus c, so we know that one of these is going to cancel. We can clearly see that 2 is a factor on the numerator. So we're going to have 2 lots of x plus 3 over x plus 3, x plus 4. These are going to cancel, so we're going to get 2 over x plus 4 is our answer. So we can actually rewrite f of x as that simple fraction. Part B. Hence find the inverse of f. So I always like to write x equals 2 over y plus 4. And again, this is going back to GCSEs here. This is a typical GCSE question. And we're going to multiply everything by y plus 4 equals 2. So I'm going to get xy plus 4x equals 2. I need to rearrange to get y equals, I'm going to minus 4x from both sides. xy equals 2 minus 4x. And then I'm going to divide both sides by x. So y equals 2 minus 4x over x. Which we could simplify to y equals 2 over x minus 4x over x, which is in fact, the x's are going to cancel, to y equals 2 over x minus 4. And then again, make sure you write it. The inverse function of x is 2 over x minus 4. Now if I have a look at the mark scheme, you have to fully simplify it. It doesn't state. Now the thing is, this is a sample, this is a specimen. The mark schemes for the specimen aren't as well written as the mark schemes for the question papers, okay? And then part C says, hence solve f of x equals 2 over 5. So we're going to substitute in f of x into f of x. Now we already know that this f of x, we've already written it out and simplified it as 2 over x plus 4. Please do not try and substitute this into this, okay? That would be an absolute fool's mistake. So please use 2 over x plus 4 and substitute in. So f of x equals 2 over x plus 4 plus 4. Now I'm going to multiply every single term by x plus 4 because we have a denominator here that I want to get rid of. So if I multiply this by x plus 4, this by x plus 4, and this by x plus 4, we're still not changing the quantity of the equation. So I'm going to have 2 lots of x plus 4 over 2 lots of x plus 4 over x plus 4 plus 4 lots of x plus 4. These x plus 4s are going to cancel. So on my numerator, I'm going to have 2 lots of x plus 8 over 2 plus 4x plus 16. This is going to give me 2x plus 8 over 4x plus 18. I can clearly see we have a common factor of 2. So I'm going to cancel this down. X plus 4 over 2x plus 9. Now it tells us this equals 2 over 5. So this equals 2 over 5. Now if you wanted to, okay, you could multiply 2 over 5 by 2x plus 9 and solve it this way. Okay, but actually, just really look at this. We're not going to get a quadratic. There is only one solution. Something plus 4 gives me 2. What is that? Minus 2. Okay? And 2 lots of minus 2 plus 9, does that give me 5? Yeah, great. So x equals minus 2 is the answer. Okay, you don't actually have to solve it. If you did want to solve it because you do not feel comfortable yet making those connections, you're going to have x plus 4 equals 2 over 5, lots of 2x plus 9. I'd probably multiply both sides by 5 to get rid of the fractions. So 5x plus 4 equals 4x plus 18. 2 times, oh, this is 20, sorry. And then I'd take away 4x from both sides to get x, and take away 20 from both sides to get minus 2. Okay, so you can do it either way, but you know, as A-level mathematicians, we really should be making connections and looking at what will happen. Question 6. Figure 1 shows a sketch of the curve of the equation y equals sine of x plus 1, where 0 is less than or equal to x, which is less than or equal to 2 pi. The point B, AB, lies on the curve and is shown in figure 1. Given that the gradient of the curve at P is minus a half, find the exact value of A and the exact value of B. So, for part A, what are we going to do? If we're looking at a gradient, we need to, in fact, find the gradient function, which means we are going to differentiate, absolutely. Now, what we know about this graph, okay, we've drawn the modulus of this graph. Oh my. But if you think about the normal sine graph, looks like this. When we've drawn the modulus, we've taken the positive. So this side was originally negative. So what we're actually going to differentiate is we're going to differentiate y equals negative sine of x plus 1. Okay? Because we're looking at, you know, think about what the graph was and what the graph is now. Okay, the graph was the negative. So if you think, when we do the modulus, we just take the positive, positive. This side here was always positive. But this side here was once negative, now we've turned it positive, okay? So we need to differentiate minus cos. Now we know we have sine, cos, minus cos. If we differentiate minus sine, we do get minus cos. dy by dx is minus cos of x. And then plus 1 differentiates to 0. We know that the gradient equals minus half, so we know that minus cos of x equals negative a half. So that means that cos of x equals a half. When does cos of x equal a half? So that means that x equals pi over 3. Okay, that's perfect. That doesn't mean that's our x-coordinate. Why does it not mean that? Again, go back to the original graph. This is going to give us the first available time when cos of x equals a half. So if I have a look across here, if I was to draw a half right now, the first time it equals a half is when x equals pi over 3. The second time will be when we do pi minus pi over 3. The third time is going to be when pi plus pi over 3. And then this time, which is p, you can see p is over our second maximum. Okay? So this is going to be the last time, which is actually, you know, using symmetry, this is going to be 2 pi minus pi over 3. Okay? So 2 pi minus pi over 3. So that means p that means our x-coordinate is 2 pi minus pi over 3, which is 5 pi over 3. And we want our y-coordinate. How am I going to find my y-coordinate? So if we substitute in 5 pi over 3 into our original equation here for what y equals, we're going to get root 3 over 2, and then plus 1. Even though the answer is minus root 3 over 2, look at the graph, we're in the positive y because it's been reflected. We only put the minus here to make sure we got the right coordinate, okay? So we are in the positive y-axis. So it's plus root 3 over 2. And then plus 1, okay? So this is, again, in pure 3. You know, you need to really think about what's going on. It's not always just about putting in the answers. Think about your answer. Would minus 3 over 2 here make sense? Absolutely not, because we do need a positive y coordinate. We can see by the graph we're doing the modulus. When you find your x coordinate, you could always substitute it back into the y modulus, okay? Part B. Find the exact, no, sorry, we did that. A straight line with positive gradient passes through P. Okay, if we have a positive gradient, our line, well, let's read that first. Given that the straight line intersects the curve at exactly 3 distinct points, find the range of values of the gradient of the line. Okay, so that means if it's got to intersect at 3 distinct points, if I was to draw this line here, it's a bit of a wonky line. Okay, I'm actually going to do it using the highlighter. Right, if I was to draw this line here, and it passes through P, but it just touches here. We know our range of values, we're going to end up having to be bigger than that, aren't we? Okay, if you think our gradient's going to have to be steeper than that line. Yeah? But our gradient is also going to have to be less than, if we have 3 distinct points, and it's positive, then 1, 2, 3, 4. But it's going to have to be less than that line there. Okay? So, our gradient is, if we think about the first line, with this point here, so we need to find the coordinate of this, and we know the gradient, and we know the coordinate of P, we can find the gradient first of this purple line. Because we know our gradient is going to have to be greater than that. So this coordinate here, how are we going to find this coordinate? Well, we've added 1 to the equation. This coordinate is normally, if you think about the sine graph, this is pi 0. If we've added 1 to the equation, this is now pi and 1. Okay, so our first line, so we know that our gradient m has to be greater than the line P, and I suppose, well, this is going to be our minimum point, isn't it? So how do we find the gradient? y2 minus y1 over x2 minus x1. We have our coordinate pi and 1, and we also have 5 pi over 3 and root 3 over 2 plus 1. Okay, so if I think y2 root 3 over 2 plus 1 minus 1 over 5 pi over 3 minus pi. This is going to give me root 3 over 2. 5 pi over 3 minus pi is in fact 2 pi over 3. And this is going to simplify to give me 3 root 3 over 4 pi, which equals 3 root 3 over 4 pi. Okay, so our gradient needs to be greater than this. We'll come back to the inequalities in a minute. We know that that is the gradient of this line here. okay? Now, our second line. We need to pick 2 points. We're going to use P again, and we're going to use this point, because this is where it's going to intersect 4 times. 1, 2, 3, 4, okay? If my gradient was to be any steeper than that, we wouldn't end up crossing P. So, what point is this point here? We know this is the point 0, 1. So again, we're going to have 0, 1, and we're going to have 5 pi over 3 root 3 pi over 2 plus 1. So we're going to have root 3 over 2 plus 1 minus 1 over 5 pi over 3 minus 0. We're going to have root 3 over 2 divided by 5 pi over 3, which is actually going to give us 3 root 3 over 10 pi. Okay, perfect. Now we have our 2 values of the gradients, okay? So, for the final answer, so it has to be in between these 2 gradients for it to cross exactly 3 times. So m is going to be less than and greater than. Okay, so we know that 3 over 10 root 3 over pi is going to be in between these 2 values. So it's 3 root 3 over 10 pi and 3 root 3 over 4 pi, okay? So, please just make sure you draw it out. I think this part here, when I said m is greater than, don't let that, I think I said that the wrong way around. But if you're not sure, have a look at the 2 gradients. You know it's got to be in between these 2 gradients. So you know that the smaller one's going to have to go on the left-hand side, the bigger one on the right-hand side, okay? Okay, question 7. A curve has the equation y equals e to the power of 2 root 3x cos of 2x. Find the differential. Okay, straight away, what are you thinking? Product rule. Brilliant. So, again, it doesn't matter the order. So I know that v equals e to the power of 2 root 3x. Differential of this is going to be e to the power of 2 root 3x, and then we multiply by the differential of the bracket, which is 2 root 3, because the differential of 2 root 3x is 2 root 3. Then we know that u equals cos of 2x. So du equals, now we know we have sine, cos, minus cos. We differentiate, we go clockwise. So cos differentiates to minus sine of 2x, and then we multiply by the differential of the bracket. Differential of 2x is, in fact, 2, so that's going to be minus 2 lots. Okay, so now I'm going to have v du plus u dv. So my v is e to the cos 2x multiplied by du. So I'm going to get minus 2 lots of sine 2x times e to the 2 root 3x plus my u, which is cos of 2x times 2 root 3. So I'm actually going to put that 2 root 3 up here. Plus 2 root 3 cos 2x times e to the 2 root 3x. So this is what dy by dx equals. I'm going to tidy this up slightly. I'm going to take out a factor of e to the 2 root 3x. And I'm going to get 2 root 3 cos of 2x minus 2 sine of 2x. Perfect. It's also really, it's really good to actually make sure that you do tidy it up, you simplify it. Then it says, part B, hence, using algebra and showing your working, find the exact coordinates of the stationary points on the curve. As soon as it says stationary points, we should immediately be thinking, guess what? Our gradient function has to equal 0, because that's where our stationary points are. Our stationary points are where we have a maximum or a minimum, okay? Or sometimes a point of inflection. So then, I need to make this equal to 0. So I get e to the 2 root 3x, lots of 2 root 3 cos of 2x minus 2 sine of 2x equals 0. I'm going to multiply everything by e to the power of 2 root 3. Why? Sorry, not multiply, divide. Why? Because then this is going to disappear from this side. 0 divided by e is still 0. So now I'm going to have 2 root 3 cos of 2x, and I'm going to rearrange equals 2 sine of 2x. Now, we have a cos of 2x and a sine of 2x. They have the same value in the middle. What am I thinking? Divide by cos, let's get a tan. Okay, so first of all I'm going to divide both sides by 2, and then divide both sides by cos of 2x. If I divide this side and this side by 2, they're going to cancel, they're going to cancel. So I get root 3 cos of 2x equals sine of 2x. Sine of 2x, if I divide both sides by cos x, I get root 3 equals sine of 2x over cos of 2x. Silly cow. Tan of 2x. So tan of 2x equals root 3. Clearly says 0 is less than x is less than pi, which means we are going to be using radians. Here, though, we have 2x. So 2x equals the inverse of tan root 3, which is pi over 3. Okay, I need to change my interval. So 0 is less than 2x is less than 2 pi, because I've multiplied my x by 2, so I need to multiply everything else by 2. If I have a look at my CAS diagram, I get 0, pi, 2 pi, CAST, pi over 3, it's roughly here. Okay, and tan, I'm going to have here as well. So, if I start at 0, first one I hit is pi over 3. Okay, I've already had that written down. Second one I hit is pi plus pi over 3, which is 4 pi over 3. Okay, now I need to find what x is, so I'm going to divide everything by 2. Pi over 3 divided by 2 is pi over 6. 4 pi over 3 divided by 2 is 4 pi over 6, which can be simplified to 2 pi over 3. So there's our final answer. It clearly says solutions based entirely on graphical or numerical methods are not acceptable. Okay? They're not saying you have to use the CAS diagram, but they want to know that you are finding all of the exact values. So, Liam monitored the population of a small country over a 10-year period. The population P measured... Sorry, everyone. Okay, right. The population P measured in thousands of people is modelled by the equation P equals AB to the power of minus 1, where A and B are constants and T is the number of years since monitoring began. Show that this equation can be expressed in the form. Okay, clearly, what have they done? They've logged both sides. So for part A, if we have P equals AB to the minus 1, we're going to get log P equals log AB to the minus 1. Does it say to the minus 1? No, sorry everyone, minus t. Okay, and then what do we know about log laws? When we multiply, we actually write add. So we're going to get log p equals log of a plus log of b to the minus t. When we have a log to the power, we actually can multiply that power, bring it down. We're going to get log p equals log of a minus t log b. Let's just double check that's right. P, yep, a, yeah, perfect. Now don't forget, you can clearly see it says log to the base 10. Just make sure you write log to the base 10. Perfect, therefore, shown. Okay, nice and simple. Right then, part B. Figure 2 shows a line of best fit for values of t and log tp. Okay, now you can clearly see here that log tp is where our y-axis is. So what is log tp? Y. What is t? Our x. So when we're thinking of equations of a straight line, y equals mx plus c, remember that, okay? Because we may use coordinates, we may not. Then, figure 2 shows a line of best fit for values of t and log tp. Oh yeah, I already read that. The line of best fit passes through the points 0.16 and 10.14. Using this information, find the value of a and the value of b, given each answer to 4 significant figures. Okay, let's think about this. Equation of a straight line, we all know y equals mx plus c. Our x is our t. So that means, okay, that our log 10b is in fact our gradient, because what do we multiply x by? The coefficient of x is our gradient in the equation of a straight line, okay? And then you know that your log to the base 10 of a is going to be your c, okay? And we know this is our y-intercept. So realistically, we know it should equal between 1 and 2, a bit more than 1.5, shouldn't we? Okay? We'll find out in a minute. Oh, it tells us it's 1.6. But, you know, again, what I'm saying is when we're having a look at pure 3, we need to be common sense, yeah? Really think about what's going on. So first of all, I need to find the gradient. How do I find the gradient between 2 points? y2 minus y1 over x2 minus x1. If this is my x2, y2, x1, y1. Okay, so 1.4 minus 1.6 over 10 minus 0. I get minus 0.2 over 10, which, is that right? So when we work that out, our gradient is minus 0.02. Now we know the coefficient of t is our gradient. So our gradient is equal to minus t log 10b equals minus 0.0t. Okay, so we can cancel the t's out and the negative. So that means our log to the base 10 of b equals 0.02. How do I find out what my b is? 10 to the power of 0.02 equals b. So then b equals 1.047128, blah, blah, blah. It then says 4 significant figures. Okay, 1, 2, 3, 4. So our b is 1.047. Perfect. Now we figured out our b. Our c, nice and easy, it's where we intercept. So our y-intercept, now they've actually been very nice to us and they gave us 0 and 1.6. So that means our log to the base 10 of a equals 1.6, because that is our y-intercept. So that means 10 to the power of 1.6 equals a. So therefore, a equals 39.81. 0, 7, blah, blah, blah. And it wants 4 significant figures, so A equals 39.A1. And it says find the value of A and B. Okay, great. We actually just have to state A and B. We don't have to do anything more. Always make sure it's really clear. Highlight them or rewrite them again. Then part C says, hence, find the rate at which the population was changing exactly 8 years after monitoring began. Okay, if we're finding a rate of change, we should always think rate of change, differentiation. Okay, so we have essentially y equals mx plus c. So we want to differentiate what's happening. Okay, so we want to find, we know that p equals ab to the negative t. We want to find the differential with respect to t. Okay? So, we know how we're going to differentiate this. Remember, our t is essentially an x. Okay, this is what we're differentiating with respect to. So when we differentiate this, because we've got something to the power of negative t, in our case, you know, if you go back to negative x. So what we do is we're going to have a b to the power of minus t multiplied by ln of the base, which is b, and then multiplied by the differential of the function. In our case, our function is negative 2. If we differentiate that, we get negative 1. So the differential is actually negative ab to the power of minus t times ln b. Now, lucky for us, we've just worked out what a and b are, and we also know what t is, because it says 8 years. So we know we're going to substitute in, so this equals minus a, 39.81, multiplied by b, 1.047, to the power of negative t, our t is 8 because it's 8 years, multiplied by ln, and then b, which we know is 1.047. Just to reiterate, if you're confused with this, go back to the differentiation chapter. It was part 2, section 2, differentiating exponentials and logs, okay, and you'll see the proof there as to why this works. Oops. Okay. So, when I type all of that into my calculator, so I get minus 1.26623, blah, blah, blah. If we just do minus 1.27, okay, 3 significant figures. Okay, because it's a negative, we know that it was decreasing. We know that anyway, because we have a negative gradient, we can see that. So we know the population was decreasing at a rate of minus 1.27. So then we double check the question. And it says, find the rate at which the population was changing exactly 8 years after the monitoring began. Okay, so it was decreasing at a rate of minus 1.27. Okay, but what do we know about this graph? Does anybody know what we know about this graph? They normally tell us something. What do we know about this model? So, it is measured in thousands of people. So what do we need to multiply this number by to get an accurate representation of the rate at which the population was changing? Got to multiply it by 1,000, okay? Always make sure you read the question, because you will lose a mark if you don't do this. So we're going to have minus 1,270 people. Would we put minus 1,270 people? Probably not. We'll write a sentence and we could put decrease of 1,270 people a year. Okay? Nice and simple. Okay, so when I'm looking at this question, a curve has the equation x equals sine y minus cos y, over cos y plus sine y. Between minus pi over 4 is less than y is less than 3/4 pi over 4. Step 1, calculate it in radians. Step 2, show that the equation of the curve can be written as. Okay, so we've got to rewrite it as this. I've got a 1 on my denominator. What do I know makes the number 1? Cos squared plus sine squared. So to get that, I need to multiply by cos y plus sine y. So, first of all, part A. Sine y minus cos y over cos y plus sine y multiplied by cos y plus sine y over cos y plus sine y. Again, you know, with these questions, you just got to, the more you do them, the more you'll know, right, I need to do this, I need to do that. But you'll be able to use your intuition. Right, we should all be fairly confident here, just multiplying out two brackets, okay, GCSE. So I'm just going to go ahead. Sine times cos is sine cos, minus cos times sine, they're going to cancel out because we do have the difference of two squares. So in numerator, I'm going to get sine squared y minus cos squared y, all over my denominator, which is cos squared y plus sine squared y plus 2 cos y sine y. Now, there's a few formulas that I know. First of all, I know sine squared y plus cos squared y equals 1. So therefore, I'm going to substitute a 1 here. I also know that cos of 2y can be written, cos of 2y can be written as cos squared y minus sine squared y. So therefore my numerator is going to be minus cos 2y. And then lastly, I know that 2 cos y sine y is also the double angle formula for sine of 2y, which equals 2 sine y cos y. So you can see I've written all the identities. Therefore, we're going to have minus cos of 2y over 1 plus sine of 2y. Okay, so we've proven it. I always think it's a good idea to write the identities. As I said, this is a specimen paper, so the mark scheme, it says on the mark scheme, attempts to multiply, uses cos squared minus sine squared equals cos 2y. I just think it's good practice to write them out, okay? So just do it anyway. Right, then part B. Hence or otherwise, show that dx dy. Okay, everyone, remember, because this is x, isn't it? Okay, dx dy. Well, the first thing we should be thinking is quotient rule. Remember, our denominator is always our v, our numerator is our u. And we're going to do v du minus u dv over v squared. And we're going to write everything out, okay? Sorry, I mean this one. This is our answer. Okay, so then, let's have a look. So, v, 1 plus sine of 2y, dv, the differential of v. 1 differentiates to nothing. Sine, cos, minus cos. Sine differentiates to cos of 2y, multiplied by the differential of the bracket. Differential of 2y is 2. And then we have v squared, which is 1 plus sine of 2y all squared. I'm not going to expand that yet. I'm just going to leave it how it is for now. Then we have u. Our u is minus cos of 2y. If I differentiate u, I'm going to get sine of 2y, and then multiplied by the differential of 2y, which is 2. Okay, so this is a u as well. V du, 2 lots of sine 2y multiplied by 1 plus sine 2y. Okay, so we're going to get 2 sine 2y plus 2 sine squared 2y, because I've just multiplied it out straight away. Then minus u dv, which is going to be minus 2 cos squared 2y, but minus minus is a plus 2 cos squared 2y, all divided by 1 plus sine 2y all squared. Okay. Then, what do I have? Sine squared plus cos squared equals, what does it equal? 1. So if I factorise out 2, this is actually going to give me 2 sine 2y plus 2 over 1 plus sine of 2y all squared. If I factorise a 2 here, imagine, this now turns into a 1. You can see that I can cancel this one with the squared. So dx by dy equals, always put therefore, 2 over 1 plus sine of 2y. What's nice about this question is, I can't believe that was 2 marks. That felt like a lot of work. 2 marks. Now it says, a point P, X, Y lies on the curve. Given that at P, my dy by dx equals a quarter, and y is less than 0, find the exact coordinates of P. So, first of all, it says dy by dx. I've got dx by dy, so what do I need to do? I need to flip it, don't I? So that means dy by dx equals 1 plus sine of 2y over 2, which actually equals a quarter, okay? So that means 1 plus sine of 2y equals a half, because I multiplied both sides by 2. So sine of 2y, in fact, equals negative a half if I take away 1 from both sides. Okay, so now this part is the interesting part. Okay, first of all, if we did the inverse, I get 2y equals sine to the minus 1 of minus a half, which is minus pi over 6, okay? Now, we can double check that, we always need to double check. So this is sine, we're going minus pi over 6. Now remember, this is pi over 2, 0, pi over 2, pi, this is going to be 4 pi, no, sorry, getting ahead of myself, 3 pi over 2 and 2 pi. Now our interval is between negative a quarter, which we know is here. Okay, if we went backwards, negative pi over 4. And it goes all the way round to 3/4 pi's, which is in fact here. 3 pi over 4. So this is the only area we're working in. Minus pi over 6 is less than a quarter. So that means here's my kind of minus pi over 6. We are working in sine. So normally with sine, we would then, we would always go here and reflect here, wouldn't we? we would reflect here. Now you can see this is out of our boundary. If I go round now, if I start at minus a quarter pi, I hit this one, which is minus pi over 6, carry on going round. I'm not going to hit anything else, I've stopped. But I've just realised as well, everyone, I've made a fatal mistake. But it's okay, we can correct it. It says 2y, we didn't change our interval. Okay, so that means minus pi over 2, because we multiply everything by 2, is less than 2y is less than 3 pi over 4. Okay, so actually our interval is, 3 pi over 2. So our interval is from here and negative pi over 2, which is also here. So our circle starts here and goes all the way around. So we are going to reach this other one. So then we're going to have 0, but as we come round, we're going to notice straight away that this second interval down here is a positive number. It clearly says y is less than 0. So even though we did make the mistake, the answer is still the same. So therefore, y equals minus pi over 12, so we divide by 2. It tells us that y is less than 0. The other solution was greater than 0, so we reject it. If you wanted to know what that was, it was pi plus pi over 6, okay? 7 pi over 6. So we can, if you want, write that down. 7 pi over 6, and then you can just write reject. Why are we rejecting? Because it says in the question y is less than 0. So now I've got my answer for y. How do I find my x coordinate? I substitute this back into the original equation, okay? So you can either substitute it in this one or this one, because they're both the original. So to find x equals, I'm going to substitute it in the second one, it looks like less work, minus cos of 2 lots of minus pi over 12 all over 1 plus sine of 2 lots of minus pi over 12. Okay, I'm going to put that into my calculator. I'm going to get minus root 3. Okay, so therefore, he is minus root 3 and minus pi over 12. Okay.
Question 10. Figure 3 shows a sketch of the curve with the equation y equals e to the power of 2 alpha. Is it 2 alpha? No, 2x minus 3 minus 4 over 3x. The curve crosses the x-axis at the point P, which is alpha 0. Part A, show that alpha equals a half ln 4 over 3 alpha plus 3. So if we substitute in our x and y coordinates of alpha and 0, we're going to have, instead of y equals, we're going to have 0 equals e to the power of 2x, which is now alpha minus 3, minus 4 over 3x, which is 3 alpha. I'm then going to add 4 over 3 alpha to both sides, so I'm going to get e to the 2 alpha minus 3 equals 4 over 3 alpha. The only way to get rid of an exponential is to ln both sides, because we're going to have a log to the base e. So we're going to have ln of e to the 2 alpha minus 3 equals ln of 4 over 3 alpha. Now, a ln and an e are going to cancel to give me 2 alpha minus 3 equals ln of 4 over 3 alpha. Add 3 to both sides. 2 alpha equals ln 4 over 3 alpha plus 3, and then divide by 2, which is a half ln 4 over 3 alpha plus 3. So nice and easy, 2 marks, very simple. Then for, it says the iteration formula x of n plus 1 equals a half, learn 4 over 3 lots of xn plus 3 is used to find an approximate to alpha. Taking x0 equals 2, find the value of x1 and the value of x5. Give each answer to 4 decimal places. So just what I like to do is I like to write 2 equals on the calculator, and then straight away that is now my answer. So then on the calculator I now type a half ln 4 over 3 lots of answer plus 3. If I press equals, I'm going to get my first one, which is 1.2973 to 4 decimal places. Press equals again, get the second one, equals again the third one, equals again the fourth one, equals again, I get the fifth one. And this makes sure that it's exact every time, which is 1.4537. Part C says, using a suitable interval and a suitable function that should be stated, show that to 3 decimal places alpha is 1.456. So to show that it's 1.456, what I'm going to do is I'm going to use the function f of x equals e to the 2x minus 3. So I'm going to go back to this equation here, part C, and I'm going to substitute in, I'm going to do my upper and lower bound essentially of 1.456. So I'm going to substitute in f of 1.455 and that's going to give me minus 0.0012 to 3 decimal places, 12199, and then I'm going to substitute in f and my upper bound, which is 1.4565, and when I put that into my calculator, I'm going to get 0.0012405. Now this is what I always find the easiest part in Pure 3, because you know this is less than 0, this is greater than 0. So for part C, f of x is continuous. There is a change of sign, therefore alpha equals 1.456 to 3 dp. Perfect. Okay, and then lastly we've got 5 parts. 5 marks, not 5 parts. Okay. Part D. Using integration, find in its simplest form the exact area of the shaded region. Okay, so we've got to integrate e to the power of 2x minus 3. So we're going to integrate e to the power of 2x minus 3 minus 4 over 3x to the power of minus 1 with respect to x between the interval of minus 2 and minus 4, because we do want to find the exact area. Okay, so we know that when we integrate a exponential, what happens? It stays the same, but we divide by the differential of the bracket, which in this case is the power. So we're going to have minus 2 minus 4. So we're going to have e to the 2x minus 3 divided by the differential of 2x minus 3, which is 2. So it's divided by 2, so we've got half e to the power of 2x minus 3. Now, I have written this as minus 4 over 3x to the minus 1, but remember this is out of habit, we are integrating It's the same as 1 over x. We know when we integrate 1 over x, we get ln x. So we're actually going to get minus 4 over 3 ln of x. And then we need to find that between minus 2 and minus 4. So we're going to have, if we substitute in minus 2, we're going to have a half e to the 2 lots of minus 2 minus 3 minus 4 over 3 ln of minus 2 minus 4. We're going to have a half e to the 2 lots of minus 4 minus 3 minus 4 over 3 ln of minus 4. So when we simplify this, we are going to have 2 times, so we're going to have a half e to the power of minus 7 minus 4 over 3 ln of the modulus of minus 2. That is just going to be minus 4 over 3 ln of 2. And then we're going to have minus a half e. Minus 4 times 2 is minus 8. Minus 3 is minus 11. Plus 4 over 3 ln of 4. Now 4 can actually be written as 2 squared. So I'm going to change this to 2 squared. We know if there's a power, we can bring that to the front. So now this is going to be 8 over 3, because I multiplied it by 2, ln of 2. Okay, and I'm just going to, it's really important, I'm just going to simplify it and then we're going to go back. So we're going to get half e to the power of minus 7 minus a half e to the power of minus 11. And now my lns are both in base, not in base 2, but they, we have minus 4 over 3 plus 8 over 3, which is going to give me plus 4 over 3 ln 2. Okay, and again, this is because ln of 4 can be rewritten as ln of 2 squared, which we know is the same as writing 2 ln of 2. And I multiplied that by 4 over 3. So here's the final answer. Okay, thank you for watching. I hope this helps. Apparently I need to say don't forget to subscribe, and I will be bringing you some more videos soon. Bye.